All right, so picking up from where we left off last class, what's going on with this mic? Okay, so we've got, hang on. All right, so starting off from where, picking up from where we left off in last class, we were talking about implementing a class. We've got a no argument constructor in our class. And so our point2 class, for example, looks something like that, right? So every point2 object's got its own x and y coordinate. Our no argument constructor simply sets x and y, the coordinates of the point, to 0, right? Don't forget that when you're accessing a field inside of a class, you're always you're allowed to write this dot in front of the field access, right? Or when you set it. And so remember, this dot or the keyword this inside of a constructor means or the keyword this inside of a constructor is a reference to the object that's being initialized. Right? You can do the same thing inside of a method, right? When the keyword this inside of a method refers to the object that was used to call the method. And so what we want to do next is we want to add some methods to our class. Right? So methods are just things that can perform some kind of computation, right? You know them as functions from Python. Earlier in the course, we saw static methods. So a static method, with static methods, you always use the name of a class to call the method, right? If you use the name of an object to call the method still works. So you can call a static method with an object reference. When you're using a static method, though, or when you're implementing a static method, what you can't do is that you can't use the keyword this inside of the static method. Right? So the reason you can't do that is because there is no object that's used to call the static method. Right? It's supposed to be called with a class name. That means there is no object that's being used to call the method, and that means there is no value to set this to. Right? There is no object that's being used to call the method. Inside of a non-static method, though, you always call these with an object reference. Right? So you always need something that looks like a variable to call the method. All right, so for example, in our point2 class, we can create a method that lets the user of the class change the x and y coordinates of the point. Right? So we've got our method here called set. Right? So the method set takes in a new x coordinate and a new y coordinate, right? And it changes the coordinates of the point that was used to call the method to the new x and new y values, right? And so in other words, when using this method, what you want to do is what the user wants to do is to be able to write something like the following. Right? So the user wants to be able to, so given a point, the user would like to change both the x and y coordinate of the point by calling this method set. Right? You use a variable name in front of the method. Right? And so the way you read that in in Java would be, we want the point P to set its coordinates to 1 and 1. Right? So you're always asking an object to do something with its x and y coordinates. To implement the method, it's pretty straightforward. So the method is not static, so now you don't use the keyword static. We want everybody to be able to use the method, so we make it public. Right? I'm going to deviate from the slide for 1 minute here. Right? So I'm not going to return anything from this version of set. Right? So set simply changes the coordinates of the point. It doesn't return back a value. The method name is called set. Right? And it takes in two values, right? The new x coordinate and the new y coordinate. So in Java, you need types for the arguments or for the parameters. Right? So double new x and double new y. Sorry, this would be a lot faster if I didn't have to hold a mic. Like that. right? And now what does the method do? Well, it needs to set the x coordinate to new x. It needs to set the y coordinate to new y, right? Where is the x coordinate stored? Well, it's stored in x, right? Where is the y coordinate stored? Well, it's stored in y. So just like that, right? And it's as easy as that, right? And so there's your set method, right? It's the method that changes the x and y coordinates of a given point, right? Down here, right? Now when you call set, right? If you were to be able to look at the x coordinates, at the x and y coordinates of P, you would now see that they are in fact 1 and 1, right? But we don't have a way to look at the x and y coordinates yet inside of this class, so we have to wait a minute before we do that. All right, now notice this version of set does something slightly different, right? So this version of set returns a point to reference, right? So it returns a reference to another point. Not to another point, it returns a reference to a point. And in fact, it returns a reference to this point. So let me change the code in Eclipse, and I'll show you exactly what that does. All right, so if set returns a reference to a point, right, that means that all of this, right, becomes a reference to a point, right? What point is it referring to? Well, it's referring to this point, right? What does this mean inside of the method? Well, it means the object that was used to call the method, right? And so when I call it with, when I call the method by writing p.set, the object that was used to call the method is P, right? And so in this version of set, everything that's highlighted becomes equal to the reference P, right? And what does that mean? It means I can call set again right here. Right? So I can chain a sequence of method calls now. If you return, because this particular version of set returns a reference to the point that was used to call the method. Right? Now this doesn't look particularly useful. You would say, well, why don't you just call set 2, right? So imagine that you had some different method that you would like to call here. So after setting the coordinates of the point, you want to do something else with the point, right? Now you can just call that method right here, right? Whereas if you don't return a reference to the point, you would have to go to the next line, right? So in the previous version, I would now have to write another line of code. Oops, sorry. Write another line of code, right? Again, using P to call the method, right? So if by returning a reference to the point that was used to call the method, this lets whoever is using the class chain sorry. Okay. This lets the caller of the method chain a sequence of method calls together, right? This is occasionally useful. It's somewhat uncommon, right? But it's a useful trick to keep to remember in case you want to do something like this. It's useful when you're implementing classes that represent mathematical entities, like a point. Because often you might, so for example, if you wanted to add a bunch of points together, or you wanted to move a point over and over and over again, right? You'd be able to write p.move, or p.move, add, set, subtract, or something like that. Right. All right. So the important part here is not that it's returning a point to reference, right? This is just a little bit of extra stuff, right? The important part here is changing the values of the fields of the object. All right. So instead of changing both coordinates of the point, right? Suppose someone just wants to change one of them, right? Now you can still use set, but it becomes awkward, right? So you would set, if you wanted to just change the x coordinate of the point, you would pass in the new value of x, and the user would have to pass in the old value of y. So that's inconvenient. So we should provide a method that also lets them change just one of the two coordinates, right? So to change just the x coordinate, right, we can provide a method called x, right? And it has just one parameter, right? The new x coordinate. How do you change the value of x? Well, it's just this dot x equals new x, right? Again, we're returning, I've chosen to return a reference to the point. so that people can, or the users can chain calls, chain a series of method calls together. Right, and of course, if you want to change x, you probably want to let the user change y, so provide a different method to change just the y coordinate. Right. All right, so those three methods that I just showed you, those are all examples of what are called mutator methods. So a mutator method is a method that changes the state of an object. Right. So set x and y, these all change the x and or y coordinates of a point. These are therefore mutator methods. Often, when you're using simple classes, you can identify the mutator methods because they're usually called set. And so many introductory textbooks would call this set x and set y, right? And just plain old set, right? And that makes it pretty obvious that these things are actually changing the state of the point. I'm lazy, so I just called it x and y. Right? So if you want a method that gives you information about an object, but doesn't change its state, that's called an accessor method, right? So an accessor method accesses information from an object, but it doesn't change the object itself, right? So if someone is using a point, is using your point class, they probably want to know what is the x coordinate of the point, what is the y coordinate of the point. So you should provide a method that returns the x and y coordinates of the point. Right? So our method called x with no parameters, right, returns the x coordinate of the point. So it just returns this dot x. Right. Our method called y with no parameters, right, simply returns the y coordinate of the point, so it simply returns this dot y. Right. Notice the return type in both methods is double because the type of our coordinate is double. Right. Also notice that these don't assign this dot x or this dot y to anything. Right. So they don't change the state of the object. So when you're writing these methods, the way that you write a method has a standard form in Java. So the first line where you write your method, that's called the method header. Right? So your method header is always made up of up to five parts. Right? We're not really going to look at the fifth part in this course. Right? But the other four will be important to us. So the methods, the header starts with the modifiers. So we saw public as our modifier in these methods, right? Earlier in the course, static was the modifier that you used, right? So you'd write the method as public and static, right? So static is another modifier. Then it's followed by the return type, then it's followed by the method name, then it's followed by the list of parameters, right? And so our set method, its modifier is public. Right? The next part is the return type, so it returns a reference to a point2 object. Right? Next part is the name, so it's called set. And then the next part are the two parameters that are passed to the method. Right? Remember in Java, all parameters have types, so it's double x and double y. Right? If you're a Python programmer, it's just x and y. Right? But in Java, they have to have types. Right? And x and y, these are just variables that belong to the method. Okay, so inside that parameter list, right, the names that you're using in the parameter list, they must be unique. Right? So here we have two names, x and y. Right? So they're unique in the list of in this particular parameter list, so that's fine. I can't have x and x or y and y, for example. Right? So the names inside any one parameter list must be unique. You can reuse the names for different methods. Right? So for our x method, we're also calling the parameter x, that's fine. Right? The scope of your parameters x and y is limited to the scope of the particular method. Right? So the scope of this name x and this name y is limited to the method called set. So Java has this notion of this thing called a signature, and this turns out to be very important because it determines whether or not you can actually put this method in the class. And it also determines which version of the method gets called when you try to use a method, right? So the signature consists of the name, so set, and it consists of the types of your parameters, but it does not include the name of the parameters. So your types here are double and double, right? And you need to keep the order the same as the way that they're declared in the header. So our method set has the signature set double double. So up top here, you've got a bunch of examples of methods from the string class, And down below, you've got their corresponding signatures. Right? So the return type is never part of the signature, right? Which confuses a lot of people. So a lot of new programmers think that you can add you can have two methods that have the same name, but they return a different type. That's not allowed in Java, right? And so you just discard the return type, and in the first case, it just includes the name, right? Because there's no parameters. So the signature of 2 uppercase is just 2 uppercase, right? The signature of car at int index is just car at int, right? So again, you're discarding all of the parameter names. So that last method, get cars, takes in an int, an array of car, and an int. So its signature is get cars, int, array of car, int. Right? So get rid of the return type, get rid of all the parameter names. That gives you your signature. So the rule in Java is that you can put whatever method you want into your class as long as the signature of that method is unique. Right? So the name, you can have multiple methods with the same name. Right? So we have one method called set already in our class. Right? It takes in a double and a double. If you wanted to, you could add another version of set. Oh, sorry. Where did that go? Here. If you wanted to, you could add a second version of set. Right? So the second version of set, it looks like it changes the x coordinate to the new value of x, and it changes the y coordinate to 0. Why you'd want to do this, I don't know. This is just an example. Right? So that would be fine. We could, in fact, add this second version of the method to our class. Right? So you can actually try this out in Eclipse. Right, so I type that in, and Eclipse is perfectly happy with what we just typed in. Right, if I wanted to, I could call it down here. Oh, sorry, that method is not quite right. Right, like that. Right, and now I can call it down here. Right, and that changes the x coordinate of the point. It also changes the y coordinate of the point to 0. Right, so that's fine. So Eclipse is happy with this. The compiler is happy with this. You can call both versions of set, no problem. Right? How does the compiler figure out which version of the method you want to call? Right? It matches the argument up. So it matches the method signature and it matches the method name and the argument type that you passed in to the signature of the method that matches most closely with this. Right? So it checks, is there a method called set? Right? Yes, there's 2. Right? Okay, so what's the argument type? In this case, the argument type is an int, right? And there's only one argument, right? So it rules out this one. It says it can't possibly be this version of set, right? You must mean this version of set, right? The compiler is allowed to convert an int to a double because double is wider than int, and so you end up with the second version of set being called, right? And that's one of the reasons why the signature is important. Right? It lets the compiler figure out which version of the method are you trying to call. The other reason is, so if the compiler is using that information to figure out which version of the method to call, now it makes sense. You can't have 2 methods with the same signature, right? Because now the compiler can't figure out, well, which one of these 2 do you want me to call? Right? Okay, so I can add that second version of set, but I can't add the third version of set, right? So the third version of set has the same signature as that version of set, right? So these 2 methods have the same signature, right? The parameter names, they don't matter, right? So the second version of set, we want to change the x coordinate to 0 and the y coordinate to the new value of y. But we can't put in that third version, right? Because it has the same signature as the second version. So signatures of your methods in your classes must be unique. The same is true of your constructors, right? The constructor signatures must also be unique. The set example is not a good one, right? So that is an example. This is an example of a badly named method, right? It's called set. It takes in one argument. You don't really know what that argument is corresponding to, right? You also don't know, the method name also doesn't tell you anything about what it does to the y coordinate. So if you wanted to include a method like this, you probably shouldn't have called it set. Right. If you have two or more methods with the same name in the same class, then the methods are said to be overloaded. Right? So overloaded means more than one method with the same name. Right? There is another term that's very similar to overloaded. Right? So there's a term called overridden, which is different. Right? That means something completely different. So don't get those two terms confused. Right? Overloaded, more than one method with the same name. So suppose you would like to compute the distance between a point and another point. Right? So it makes sense to add a method called distance2, right? That takes in a point, right? So that computes the distance from one point to the point P. Right? So q dot distance to P computes the distance between Q and P. Right? Now, depending on exactly why you're making this point class, you might decide that people don't have to pass, the user doesn't have to pass in a point object, right? Instead, you can compute the distance to another point given the x and y coordinate of the other point. Right? So that second version of distance 2, you don't need a point object, you just need an x and a y coordinate as two doubles. Right? And if you wanted to, you can even provide another version of the method that computes the distance to another point where the x and y coordinates are provided as two floats. Right? You could also have distance 2 int int and distance 2 long long. Right? Those would all be fine inside the same class. Right? All right, so that's the signature of the method. Now remember, the signature doesn't return does not include the return type. Right? So all methods in Java, they either return one thing or they return nothing. And if they return nothing, you have to write void as the return type. Right? So our method x, our accessor method x that returns the x coordinate returns the x coordinate as a double value. Right? Right. So if you use the Java language for any amount of time, right? So you'll quickly realize that there are some methods that you haven't defined yet in your class, but you're actually able to use those methods even without having defined them. Right? So for example, I can go to the point2 class and use toString. So let's take a look at that. Right, so on that line of code, I've asked P for its string representation, right? And then on the next line of code, I'm going to print out the string representation. Right? Now, if you do this, you get some gibberish. Right? So up here, if you can read that, it says lect point2, so you get the name of the class, followed by an @ sign, followed by some sequence of numbers and digits. That thing there, it turns out it's related to the memory address of the point object, which is useless to the programmer. Right? You can't do anything with the memory address directly in Java. So this string doesn't really mean anything, right? It's not useful to you. But you can still call toString, right? And if you look in the class, right, there's no toString method in the class. And so the question is where on earth did this come from? So it turns out that in Java, so if you create a class, right, you're actually creating what's called a child class of something called big O object. Right? And all this means that in Java is that, so in Java, all reference types, they have more than one type. So our point2 class, right, its type is point2, right, because that's the name of the class. Oh, sorry. One of its types is point2. Right? But the way things work in Java is if you have a reference type, it automatically gets a second type, and that second type is called big O object. Right? So if you wanted to be explicit about the relationship between point2 and object, you would write something like the following. Right? And so arguably, right, that is the complete declaration of the class point2. right? The keyword extends, that's the word you use when you want to make what's called a subclass, right? And we're going to talk more about this in a few weeks, right? So when we talk about inheritance, you'll learn all about subclassing, right? This thing called object, well, it turns out in Java, every reference type is a subtype or is a child class of object, right? Normally, you don't put this in, right? So normally, if you're just creating a class, if you're creating a regular top-level class, you don't put in the extends object part yourself, right? The compiler inserts that for you. Right? Later on, when we are creating child classes of other classes, we're going to have to put this in, right? So for now, we can leave that out. What is the point of all this, right? The class object has a bunch of methods in it, right? Depending on the version of the language, there are at least 11, right? So there's 11 methods in object, and that means when you create a class, you also get those 11 methods, right? You get them for quote unquote free, right? One of those methods is toString, right? So I can use our point2 class and call toString on a point2 object. I can also use equals, right? And I can also use this thing called hashcode. Right? So these are the three methods that we're interested in this course. These are the three methods that you get from object that we're interested in this course. Right? Okay, so what should toString do? Right? So toString, ideally, should return a string that represents your object, right? That tells you some information about the object itself. Right? Now, you saw that when I called toString on our point, we got out something that didn't look very useful. Right? We did get a textual representation of the object, it just wasn't a useful one. So we would like a useful representation of our object. Right? So for example, I might want to write a point, I might want the string representation of a point to look like what a mathematician would write. Right? So for a point whose coordinates are -1 and 1.5, I might want the string that looks like that. Right? So round bracket, x coordinate, comma, space, y coordinate, closing round bracket. Right? That would be nice, because then I can print out my point and I can see what the coordinates of the point are. Right? That would be useful for debugging, for example. Right? So how do you do that? Well, you just define your own version of toString. Right? So ignore override for a minute. I'll tell you what that does in just a second. Right? So if you want to replace toString in your class, it always looks the header is always exactly the same. Right? It must be public. It must return a string. Its name must be toString, and it must have 2 round brackets with nothing inside the round brackets. Right? How do you implement the method? It's pretty easy. I need to make the string that starts with an opening round bracket, followed by the x coordinate, followed by a comma and a space, followed by the y coordinate, followed by the closing round bracket. Right? So starting with the opening round bracket, right? Append or concatenate the x coordinate, then concatenate a comma and a space, then concatenate the y coordinate, and then concatenate a closing round bracket. Right? And that gives you a working version of toString. Right? So let's put that into our class and see what we get. Right? So you put in your returns, so you make your string, right? And then you return that string. Right? Now, when I call toString down here and print out the resulting string, right? I get -50, right? Something that looks like what a mathematician would write down. Right? So that's nice. So we've now got a nice string representation of our point. Right? Okay, so what happens if you screw up? So what happens if we mistakenly call toString something else? Right? So what happens if I change the big S to a lowercase s? Right? And now I run this method, right? So now I run my program. Now remember, this is calling the version of toString that has a big S in it. Right? Sorry, let me check that box there. Okay. Right? And now you get back the original version of toString that we got from object, right? So why can you do this, right? Because that name there, right, is different than that name there, right? And so this version of toString is not an overloaded version of toString, right? It's a completely brand new version of toString, right? And so when I call toString the usual way, I get the version of toString that we got from object. I don't get our new version, right? Okay, so let me put that back. And what happens if I strike public from that? Right? So as soon as you strike the public modifier from the method, right, the compiler complains. Right? It says it cannot reduce the visibility of the inherited method from object. Right? So the version of the method that you get from object is public. If you want to replace that version of the method, it must also be public. Right? So you can't do that either. Similarly, if you try to change the return type to something else, the compiler will complain if the name is toString. Right? Instead of the, so if you want to catch these kinds of errors, you're allowed to put in this optional tag. Right? So the @override tag asks the compiler to check, right? Is there really a method called toString, right, in the class object? Well, in this case, in the class object, right? Right? So is there really a method with this name? Right? If there isn't, right, now the compiler tells you there's a problem, right? Now it says, hey, there is no method called little to little s string, right, from the class object. Right? So now it tells you, hey, you want to replace an existing version of a method, but this version of the this particular method doesn't exist in object. Right? So the @override tag is an optional tag that you can use to help you ensure that you're actually overloading a method and not creating a brand new method. Right? Okay, so down here, when I printed the string, when I printed the point, right, I wrote, I called toString myself and then printed the string. You never have to do that. You can always just print the object itself, right? So here, instead of printing the string s, I'm going to print the original point t, right? The reason this works, so let me just run this program, right? So you get the same output the second time, right? The reason this works is because there's an overloaded version of println that takes in a big O object reference. Right? That version of println automatically calls toString on that object for you. Right? So you never have to call toString yourself explicitly if you want to print something out. Just print the thing that you want, right? And you will get something, right? As long as whoever created that class overrode toString or replaced their version of toString, then you'll get a string representation of your object. Right? Also, notice that earlier, I told you that there's another term, right, similar to overload, or looks the same as overload, right? And so that's the term override. Right? They are two completely different things, right? An overloaded method is two methods with the same name in the same class. An overridden method is a method that replaces an existing definition of a method, right? So this version of toString replaces the version that we got from object. Right? So don't confuse the two terms override and overload, right? They mean completely different things. Right? So as soon as you have toString, now it's easy to print point objects. Right? So there's my point, change the coordinates to the point, print the point. Right? You can put toString here if you want to, you can leave it off. Everything works just fine. Right? Okay, so what about more methods? So in our counter class, right, what would be some useful methods for the counter class? Remember, the counter is just this thing that counts from 0 up to integer max value in increments of 1. If someone's using their counter for something, they probably want to know what is the value of the counter. Right? They probably want to change the value of the counter up by 1, right? So they advance the counter by 1. Right? It would be nice if you could print a counter. Right? So there's our constructor, right? Sets the value of the counter to 0. There's our method value. Right? It simply returns the value of the counter. So it returns this dot value. Right? Here's advance. Right? So remember advance. So the way advance works for this particular counter class is that it adds 1 to the value. Right? Now you know that the value is represented as an int. So eventually you're going to hit integer max value. Right? And now the counter is going to wrap around back to integer min value, right? Some large negative value. If you want the counter to wrap around, then it really should wrap around back to 0, because our counter says it's this thing that starts counting from 0, right? It represents a physical number of items. So here we have to do something a little bit extra, right? So if the value of the counter, right, if it's not currently integer max value, right, so if it's not the largest value that we can count to, go ahead and add 1 to it, right? Otherwise, if it is equal to integer max value, we're going to reset the counter back to 0. Right? Now, one of the common mistakes new programmers will make is in this line right here. Right? A lot of new programmers will write something like, if this value is greater than integer max value. Right? That doesn't make any sense. Right? This value is an int. It's never greater than integer max value. Right? The largest possible int is integer.max value. So it never makes sense to compare an int value to integer max value using greater than or equal to. Right? Those don't make sense. Right? Well, the greater than and equal to kind of makes sense because it does the equal to comparison. Right? But an int value is never greater than integer max value. Right? Another common mistake is that people will simply write this value plus plus. Then on the next line they'll write, if this value is greater than integer max value, set the value back to 0. Right? Again, that doesn't work. Right? As soon as you write this value plus plus and it overflows, it immediately goes to integer min value. Right? And so your condition on the next line will never be true. And it's never true anyway because an int is never greater than integer max value. Right? So that is the correct way to test whether or not you can advance the counter. And finally, toString. So when you implement toString, there's no standard way. There's no standard representation for the string that you output. Right? It's up to you to decide what should the string representation of this object look like. So for the counter, I've decided that I'm going to print out the string representation should include the string count, followed by a colon and a space, followed by the value. Right? You might choose to do something different. You might use square brackets and put the count inside the square brackets. Right? You might use round brackets and put the count inside the round brackets. You might use braces and put the count inside the braces. Right? It's up to you how you implement the toString. Right? There is no right or wrong way to do this. Now, if someone tells you, hey, implement toString so that it outputs a string that looks like this, then there's a right way to do it. Right? But generally, when you're creating your own version of toString, you decide on some sensible string representation for your object. The stopwatch class. Okay. So the stopwatch class is kind of complicated. So if you're implementing a stopwatch, right, so you want to be able to start the watch, you want to be able to stop the watch, right? So when you start the watch, assuming the watch is already stopped, right, it starts keeping track of how much time has elapsed, right? When you stop the watch, assuming that the watch is running, right, it stops the watch and then probably tells you how much time has elapsed since you pressed start. Right? Now, if your watch is running, it might be useful to look at the watch and find out how much time has elapsed since you pressed start. Right? So you also want to get the amount of time that has elapsed. Right? So there's at least 3 methods that you want here. Right? So if the watch is running, then the elapsed time is simply the time from when the watch was started until now. Now, what happens if the watch is not running? Right? So imagine you press start, right? A little while later you press stop, right? And now you ask for the elapsed time, right? So the elapsed time is just the amount of time that elapsed between pressing start and stop. Right? So we have to keep track or be able to calculate how much time has passed. Okay, so remember how the stopwatch class works? It's been a little while since we looked at it, right? You've got a start time and a stop time. Right? To get the amount of time that's elapsed, we just compute stop minus start. Right? Is running is true if the watch is running. Right? So someone has pressed start, but they haven't pressed stop yet. the start and stop time, remember these are in units of nanoseconds, right? So 10 to the minus 9 seconds. Eventually, we want to convert these to real seconds. So it's useful to keep around this value called 1 billion, right? So if I take the number of nanoseconds, multiply it by 1 billion, that gives me the number of seconds. Right? There's our constructor, so it sets the start and stop times to 0. The watch is not running. Okay, so the start method starts the watch running. Right? Now, if the watch is already running, it does nothing. Right? So if the watch is not running, right, we want to go ahead and start the watch. Right? And so starting the watch means calling nanotime to get the current time, right, and storing that in the start time variable. Right? So we're simply going to remember what time is it when you pressed start. Right? Now the watch isn't running, so we have to indicate that the watch is running. Right? So we set this is running to true. Right? Again, if the watch is already running, we do nothing. Right? So pressing start twice in a row doesn't do anything special. Okay, what about stopping the watch? So if the watch is running, then we want to actually stop the watch. Right? If the watch is not running, right, we want to know how much time has elapsed. Right? So we're going to have a third method that reports the amount of time that has passed since pressing start and stop. Since pressing start. Right? Okay, if the watch is running though, right, and you press stop, you now have a stopping time. Right? To get the stopping time, you call nanotime, and you store that in our stop time variable. Right? And now, of course, don't forget, indicate that the watch is no longer running, right, by setting is running to false. Okay, so how does this elapsed method work? Right, so remember, elapsed tells you how much time has passed since you've pressed start. Right. Okay, so to compute how much time has passed since you pressed start, right, we're going to get the current time first. Right, so I want to know what is the time right now. Right? Okay, so if the watch is not running, so if the watch is currently stopped, right, then you don't actually want the current time, right? You want the stopping time. So I'm going to set current time to the stop time instead. Right? So if the watch is running, I want the current time. Right? If the watch is not running, I want the stop time. Right? And now I can compute the total amount of time that's elapsed. Right? That's the current time minus the starting time. Right? Now remember, these are both long values, and I want the amount of seconds that has elapsed. Right? And I probably want the number of seconds plus we might want some numbers after the decimal place, right? Because we want a double value here, right? A real value. So that's long, right? Billion is also a long, right? I have to make sure that all of this is done in double arithmetic, right? Otherwise I get a long divided by a long, and now I've got long arithmetic, right? Integer arithmetic. So to force this into double arithmetic, I'm just going to add 0.0 to the current time, right? Now that's a double plus a long, so that's a double, right? Minus a long, so that's all a double. Divided by a long, so that's all a double, right? And that forces the compiler to compute this in the way that we want it to, right? Using floating point arithmetic, right? And so there's your complete implementation of the stopwatch. Right? Is anybody in here actually a runner and has actually used a stopwatch? Anybody? Yeah, so nobody. Okay, so this doesn't make sense. So if you have actually used a real stopwatch, you know that there's other things you can do with a stopwatch, right? You can keep track of these things called lap times and other things like that, right? It's possible to extend this class to actually look like a real stopwatch, right? If you haven't used a real stopwatch before, none of that makes any sense, so don't worry about it, right? But if you have used a stopwatch before and you want to play around with this class a bit, consider trying to add a lap time feature to this stopwatch. All right, more constructors. We've only got one constructor in our class. Usually it's very convenient to have more than one, right? So you can put in more than one constructor in your class. The signatures of the constructors must be unique, right? Now remember, the signature of anything in a Java class is the name followed by the parameter list, right? All constructors have the same name, so you're stuck with having unique parameter lists, right? So you can't have a constructor whose name is not the same as the name of the class, right? When you add these extra, or if you wanted to add these extra constructors, you have to think about how are people going to be using your class, right? So if someone's using the point2 class, they probably want to tell you, they might want to tell you what is the x and y coordinate of the point when they create the point. So it makes sense to have a constructor that takes in an x and a y coordinate. So there it is, right? So a constructor, right? Same name as the class, right? I want an x value and a y value, right? Now notice here, I've decided to name the parameters x and y, right? If you look at the fields, they're also named x and y, right? So now we have a problem, right? Inside this constructor, the name x means that x. The name y means that y, right? So if I want to set the field x, I have to write this dot x here. There's no choice, right? So I must write this x equals x and this y equals y, right? I can't just write x equals x. That doesn't do anything in any programming language, right? X equals x simply reassigns x to itself, right? And x means that x inside the constructor, right? So this is an example of when you must use this in front of the field name, right? You have to use this in front of the field name when you need to disambiguate a name, right? That x has the same name as that x, right? If I want that x, then I have to write this dot x, right? So this x equals x, this x equals y. Don't write x equals this x, y equals this y, right? That doesn't change your field x and y. That changes your parameters x and y, right? Similarly, don't write this x equals x, this y equals, sorry, this x equals this x, this y equals this y, right? That doesn't do anything. It just sets, it doesn't change this x or this y, right? So that stuff over here, right, tells you exactly what this x means and what x means in this particular method. In this constructor, right? Oh, this is repeated again. I'm going to skip over this slide. We've done this several times already. Okay, so in that particular constructor, when you have a constructor or method, right, this also applies to methods. If you have parameters with the same name as the fields, right, then we say that the parameter shadows the field, right? The parameter hides the field, right? X inside this constructor means the parameter x, not the field x, right? So whenever shadowing occurs, whether it's in a constructor or a method, you have to use this when you want the field. Right? Okay, so I guess that's enough that's enough for today. We'll finish this up on Friday.